little bit different today. Ignore my screen for a second. I'll even scroll down. We're going to be talking about design and project starting and how you created a problem statement and how you look at your functions and your objective and an objective tree. We're going to be talking about design and design learning specifically. And design learning, and this is probably the first piece of information beside the car that I had written up there. Design learning, we can actually say that it is learning the skills or obtaining. So we can actually put a slash obtaining these skills to solve unstructured problems. What does this mean? A structured problem would be like, for example, what's 2 plus 2? This has a known structure, a known use. We have the plus, I can't even write. This has a known structure and a known use. Delete, please. Oh, well. The plus sign, we already know what that does. The 2 plus 2. Most of us should have memorized this is equal to 4. Same thing if I were to say, what's 2x is equal to 3? Well, we know x is equal to 3 divided by 2. There's a certain series of steps that we can go through in our head to isolate for x, right? These are all what we call structured problems. An unstructured problem would be like if we're trying to find a solution to something that we have never done before, right? And not just that we haven't done before, that you can't go ahead and Google it and be like, oh, that's how you solve it, right? Coding we can Google, coding we can ChatGPT. Something that needs creativity, it needs constant thinking, iterations, learning, and a lot of patience, okay? Back to why I have a car up here. In this video, hopefully it's going to be under 30 minutes because at 30 minutes the recording will cut me off. But in this video, our primary example is going to be a car because most people have been in a car. Most people can drive a car at this university. You guys should be 18, so you guys should be able to drive. Most people know how a car works, right? So that's why we're going to use that as our main example. You might say sensors on a car. We might say a backup camera on a car. We might say mirrors on a car. We might say seats in a car, right? But a car is a generalized example that we can use to kind of understand exactly what we're talking about, okay? So that's design learning. And a part of design learning is understanding exactly how to understand the problem, okay? I'm going to keep changing colors and you guys will have to get used to it. How to understand the problem, okay? Because a lot of times people will start a project and they will have no idea what they're doing. Quite literally, right? They have no idea what problem they're trying to solve and therefore their solution may not be adequate. So I'm just going to move this down a second. Okay. So if we wanted to take a look at this, that did not get moved down. We're just going to move it down a little bit more. There we go. That's nicer. Okay. First off, we have to ask tons of questions, all right? But that's kind of a given. We have to know who. Who are we asking? Why are we doing this? What should this be able to achieve, right? These are all basic questions. And I'm just making them up as we go, to be honest, right? But you have to have a certain guidelines and rules that you have to know to be able to address a problem. And this is where we actually get into our objectives and our functions and all these different things. And guys, this is so amazing. I love this. I love talking about this. It is actually so interesting. And it's actually very logical and simple and intuitive. What should the design do, right? Design do. These are all just sample questions. Now, this is where we get into the classification of these questions and everything that we need, because one time I might forget to ask, oh, who's going to be using this, right? Because we, as designers, we have to take into account so much more. We are down here, designer, okay? Over here, we have the manufacturer. The manufacturer has to take into account the user and the client, right? This is a full circle. I know in most cases you'll see a circle here. I prefer this because the designer is the one that has to take into consideration the manufacturing cost. They have to take into consideration the user practicality, durability. They have to take into the client's budget, right? So over here we have money. Over here we have money. Money is such a big factor, guys. Money is such a big factor. Over here we can even have money, so it's affordable, right? I feel like this is a better diagram. Usually, I'll show you guys what you usually will see. Usually you will see it drawn something like this. Okay? Not wrong. It just kind of shows a circle of how everything goes through and progresses, and you have to do multiple iterations and yada yada yada. Right? Now, if I were to continue, just erase my little stuff over here. Based on these questions, one time I might forget to ask a specific question. I might forget to ask, what should the design do? I know what it's trying to solve, right? Like, for example, if I wanted to say I wanted to add backup cameras, okay? Why are we doing this? To increase safety, right? Increase safety. You can have sensors. You can have backup camera. So all depends. Do they need to see the back? See the back, right? What exactly about safety are we doing? So this is where we get into what our functions, our objectives, and our constraints. Let's start off with our functions. Functions, okay? And this is where the car is literally the best example that could ever be given for this unit. And I kid you not, it is literally the best, okay? Functions, the way you set it up, input, output. Start it off like this. Don't listen to anything else people say. This is the way your lectures are set up. This is the way you're going to solve the question. Why would you go around the long way? Don't try to make it fancy. Just go with the flow. Go with the setup that they gave you. Input, we input energy. Output, we output torque. Okay, if we have a code, for example, a code, if you guys are engineering students, you guys have to do some code. So the function of the code, that's why you guys have to write probably doc strings. Input, right? Maybe it's information. And then output, maybe it's a string. Okay? Keep this in mind. Keep it simple if need be. Nobody says the functions need to be complicated. Okay? And sometimes if you overcomplicate something, then people don't understand what you're saying, and then you get marks off on the exam. Now let's talk about constraints. Okay? In a car, for example, what's a constraint? Safety. All right, I'm going to give you guys a little tip. When in doubt, add safety to the constraints, okay? Because I kid you not, if you're creating an object, something has to arrive safely. Let's say you're creating a mechanism that transports luggage. Safety is a big constraint. Safety of luggage, safety of people, right? Safety is such a big factor in every single consideration. So when in doubt, add safety. And I kid you not, 9 out of 10 times, I guarantee safety will be one of the constraints. Okay? Safety, cost, shipping. These are all constraints, right? Because if we can't ship something out properly, if we can't ship something, period. For example, I came across a video a couple days ago of, I think it was like a body butter, and they could only ship it certain times of the year because otherwise it would melt and separate and yada, yada, yada. So that is a constraint for body butter, right? Shipping is a constraint for cars because of the way they have to be shipped. They need big trucks, cost, da, 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 da. Okay, and then finally objectives, and there is a reason I left objectives to the end. Okay, because objectives are literally the biggest portion. What should it do? Slash B. Okay, in a car, we want, let's say we're designing some safety mechanism that will stop people from bumping their cars. What should it do? Notify driver. It can maybe, if you're going very extreme, apply brakes. Right? There are so many different things that we can add to objectives, and you can go on and on and on and on and on, and I kid you not, on and on and on and on. Okay? And now I want to do something called the objective tree. Because you're probably gonna have to do this at some point, and we're gonna try I'm gonna try my very best to make this as neat as possible. So let's say we are designing a I'm gonna use an example that I have seen around. Um, let's say you're designing maybe not. I want a good idea. Let's say you're designing what are you designing? Let's say you're designing some mechanism. Okay. A mechanism that let's say you're designing a bridge. Okay. I'm really running blank here, and I don't want to use examples that people have seen before to make this video as useful as possible. But I'm thinking we should. I've seen this example around, and I think it's a great example to show how objective trees actually work. I feel like I'm gonna need a thinner pen. I have caved. Okay. Unspillable. Actually, we're just gonna call it new cup. Okay. New cup. Right? We are trying to create a new cup that people would buy. All right. What are some of the objectives? We have primary objectives, our first line. Okay. This is always going to be primary objectives. Okay. Always the first line is primary objectives. All right. It has to be, absolutely hate that. Has to be easily marketable. Let's put that in a box so make it look pretty. Easily marketable. What else does it have to be? Has to be cost efficient. And it has to be safe. And now you might be thinking, oh my god, how does safety relate to this one? All right, the farther down you travel in your what's it called, in your objective tree, the more detailed your solutions should be. I'm gonna move this just off the side because I will need the space for everything else. Safety, no choking hazards. Okay, for example, small pieces, small parts, because I can't spell. Okay, this is a safety concern. We're creating a new cup. Let's say it's for kids. Okay, easily marketable. Okay, if it's easily marketable, it has to appeal to parents because who's going to buy it, right? You have to keep in mind, who is our user? Who is our client? The user is a kid, right? But our client is the parent because the kids don't have money. So appeals to parent, right? Appeals to parent. Why would it appeal to parent? Okay, why would it appeal to parent? Spill proof, maybe. Easy to use. Okay, I'm going to expand on this one a little bit. I'm expanding off the side a little bit, but that's fine, just because I have a small screen. That's a small square. Okay, spill proof. From spill proof, we can leave it at that. Easy to use. Over here, what do we need to add? Easy to use, but easy to use, easy to hold. It's actually going to be a whole lot of ones. Okay, easy to hold. and then easy to drink from. Okay, I kid you not, you might be laughing in your seats right now, but there are some water bottles that I just cannot open them, and they're meant for kids. What kind of design is made for kids when a grown adult can't open them? Not very smart. Cost efficient. If possible, and for this case it's not, you can usually put, for to make it cost efficient, you can usually put local materials, right? Because if you create some solution that can use locally sourced materials or more than one type of material, then you have just created a solution that can save millions of dollars on shipment, on packaging, on so many different things. Cost efficient, right? Easy to package. So over here we can say packaging. We have also manufacturing costs, right? I'm just going to call it manu costs, right? Manu costs. From here we get material. And from here we get durable and compact. And we're going to say heat resistant. Okay, resistant. Because remember, that's not what I meant to do. Okay, chill. Remember how I was talking about the body butter that cannot be shipped during certain months because the butter will melt? Yeah, that's not heat resistant. We need something that you can transport all times. Okay? Think of for a second, one last thing for easily marketable. Because there's one more thing that I want to fit right over here. I know there's not a lot of space, but there's one more thing. Unique. Unique. Creative, appealing design. I can't fit everything, and that's okay. Appealing design. Think of for a second this cup right here. Okay, what is it? What is this cup? You all know this cup. People have gone around making fun of this cup. What is this cup? That's a Stanley. I know it's a terrible Stanley. It's really ugly. Why did this sell so well? Why did this sell so well? Because it appeals to consumers. This part right here, this bottom part right here, it fits into your average cup holder, right? Which most water bottles don't fit into, right? And that is such a big thing for people, because if you can't fit your water bottle, it is no longer durable. It's no longer easy to hold, easy to use, right? Sure, it's not spill proof, but it solved so many problems that people were previously having, right? Because you either had to take a really, really big cup holder that didn't fit in your car's cup holders, and then you're gonna have to carry it around all day, or you can get a Stanley. It fits into your car cup holder, but still holds a lot of water, right? Still holds a lot of water. So they used an objective tree, and then they used something else. How did they come up with the final design for the Stanley? Right? I know I said I'm going to stick to a car, but just bear with me, okay? Bear with me. How did they come up and I'm going to leave you guys with this. With the idea of the Stanley. How did they know it was the idea? Okay? And we're going to talk about this in the next video.